Hello viewers, I'm Kausalya. Today we are going to solve problems related with Norton's theorem. The problem is find the power in the impedance 2 plus J5 ohm connected between A and B using Norton's theorem. So here this is the impedance value, right? We need to calculate the power. So here the first thing is regarding Norton's theorem, the final equivalent circuit will comprise of a short circuit current and an impedance connected in parallel to it, right? So the first step to find the short circuit current is we have to remove the impedance, right? Remove the impedance across which we need to calculate the power, and we have to short circuit it by a conductor, right? Now we have to calculate the current that flows through this path. So when you look at this diagram, you see here current flowing from this voltage source, it gets divided into two at this node A, right? Therefore here these two paths are parallel to each other. As the current gets divided, they are connected parallelly. Therefore the impedance is calculated as Z1 into Z2 divided by Z1 plus Z2, right? So here minus J5 into 4 divided by 4 minus J5. So once you solve this, here the final answer is minus 20J divided by 4 minus J5, right? Now we have reduced these two impedances into a single impedance. Now that impedance comes in series with this resistor, right? With this impedance part. Here these two combined as a single one, right? And now this path and this path, they comes in series. So here 3 plus J5 plus minus of 20J divided by 4 minus J5. So once you simplify this, here finally the value of impedance is 5.439 plus J 3.049. So here the thing is, again this rectangular form is converted into polar form here. The next thing is we are going to calculate the total current. So here the total current is nothing but V by Z. So this is your voltage source and this is your value of this impedance, right? So here I am converting this rectangular form to polar form. In either way you can do, right? You can convert this into rectangular form and you can solve, or you can convert this rectangular form to polar form and you can solve this. And here the value of total current is given by this expression. Now we have calculated this total current, right? But actually what we need the current that flows through this path, right? Therefore by current division rule, this is your total current into opposite resistance is minus J5 divided by total resistance is 4 minus J5, right? So just convert everything in polar form and finally the answer is 1.25 with an angle of minus 67.93 degrees, right? Now we have calculated the short circuit current. The next step is to find the Z Thevenin. So here this is the given circuit diagram. So to find the Z Thevenin, what we have to do? We have to remove this impedance part, right? We have to remove the impedance part here as well as the voltage source, right? No, here we should not draw a voltage source, sorry. Now we are going to calculate the impedance value. So here when you look at this part, you see the current flowing from this side, okay, it gets divided into two here. So therefore these two impedances are parallelly connected. So here the thing is again Z1 into Z2 divided by Z1 plus Z2. So once you solve here, we are ending up with the answer like this, right? Now that net thing is we have reduced these two into a single impedance, and that impedance is in series with this 4 ohms, right? It is familiar from this diagram. So here just we are adding, since 4 ohm is connected in series, and here the Z Thevenin is 12.33 minus J5 ohms here, right? Now we have calculated the short circuit current as well as the impedance value. So now we are going to draw the Norton's equivalent circuit. So here you see this is your short circuit current and this is your impedance value, that is Thevenin's, okay, Z Thevenin, and here this is the impedance across which we need to calculate the power, right? So here in this case, to find the power, what is the general formula for power? It is I square R or V into I. Since here we are having a current source, we go for I square R. So again, by using current division rule, we need to calculate the current that flows through this path, because we need to calculate the current that flows through this, right? So here, therefore, total current into opposite resistance, okay, this is your opposite resistance, divided by total resistance, you have to add, right? So once you solve and simplify, here the final value of the current flowing through this 2 plus J5 ohm is 1.160 with an angle of minus 90, right? So this is the value of current here. After finding the current, what is our aim? Our aim is to find the power in 2 plus J5 ohm. Therefore, the formula for power, it is nothing but I square R. We know the value of I, right? So here in this case, considering magnitude is enough. So I square into the value of R. So here what is the value of R? This is R plus Jx, right? So here the value of R is 2. So just substitute the value here, and finally the answer is 2.69 watts, right? This problem gets over here. We will proceed with the next one. The next problem is, for the circuit shown in figure, determine the load current IL by using Nortan's theorem, right? So this is the given circuit diagram. So this is your IL, right? So as usual, for Norton's theorem, the first step is we have to find the short circuit current, right? But here I have started with finding impedance, okay, let it be. So for calculating impedance, you have to remove this load resistance. So here the 5 ohm is removed here. So in this case, when you observe, it is clear, right? You see this resistor, sorry, this inductor and this capacitor, they are in parallel, right? Because current flowing from this junction A, it gets separated into two here. So these two are said to be parallelly connected. Therefore, the formula is Z1 into Z2 divided by Z1 plus Z2. So here it is plus 3J into minus J2 divided by J3 minus J2. So once you solve here, the final answer is 6 with an angle of minus 90 degrees, right? Now the next thing is, we are going to calculate the short circuit current. So to calculate the short circuit current here, the thing is we have to short circuit the path, okay, short circuit the load resistance. So here we have short circuited, right? So from this diagram it is clear, right? You see current flowing from this voltage source and current flowing from this voltage source will flow through this short circuit path, because this is a least resistance path, right? Therefore, the formula for current, it is nothing but V by Z. So here the V is 10 with an angle of 0 degree by impedance is J3. And again for next thing, 5 with an angle of 90 degrees and the impedance is minus J2, right? So here once you solve this, finally the answer is, you see here we are having the value of this current as minus 2.5 minus J 3.33 amps or 4.164 with an angle of 126.89 amps, right? This is the value of short circuit current. Now we have calculated the impedance value as well as the short circuit current. So here the thing is, we have to draw the Norton's equivalent circuit. So this is our Norton's equivalent circuit, right? So ISC, and this is Z Thevenin, and this is your load resistance or load impedance. So here again we need to calculate the current that flows through this load. So what to do? We have to use the current division formula. So this is your total current, right, into opposite resistance is 6 with an angle of 90 degree divided by total resistance is 5 plus 6 with an angle of minus 90 degrees, right? So here the thing is, again when you simplify, you see here, you see 5 plus 6 minus 90, it is nothing but 5 minus J6, right? When you convert this polar to rectangular form, it will appear like this. Again we are simplifying, and finally the answer is 3.198 with an angle of minus 166.696 amps. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.